Hello everyone. Welcome to Python Challenge for All. Okay, in today's lesson, we'll be covering a new topic, which is about plotting function graphs. Okay, how to draw function graphs. Okay, so one way to plot the graphs is using matplotlib. So I will cover that story using Google Collaboratory. So please open your Google Collaboratory. Okay, maybe in Google, yeah, you can go to a search for Google Collaboratory, and open a new notebook. Okay, like this. Okay, fine. Then I enlarge it. So one typical way is to start importing matplotlib dot pyplot as PLT. This is a standard way to use any graph or graph plotting tools. Okay, so let's start the first topic about let's define a function f of x equals x squared minus 5 and try to draw this, well, graph. Okay, as you know, this is just a very normal quadratic function, so it should be very easy. So let's define a function f of x, which returns just x squared minus 5. Good. So this is all. Okay, now what we do is we will create we will divide the interval into nn points. Okay, let's define nn to be, say, 100. And then let's define the interval to be x low, x high, for example, as -5 and +5. Okay, so okay, we don't want this. Okay, so what's next? So the interval should be x high minus x low, all divided by nn. Okay, so the x list can be expressed as dividing the interval into nn points. So it should be easy. XL equals just I times d plus x low for I in range nn, right? We take nn points and add d, yeah, I times d to x low. And then compute y list yl as list of points f of x evaluated at each point for xl. So yl equals f of x for x in xl. In this way, we can make the two lists the same size. Okay, that's all actually. Very easy. So what we need is plot the graph using matplotlib. This can be done by plt dot plot xl. Yeah, give x-axis values, list of x-axis values and y-axis values, and then call plt.show. This is all. Okay, very simple, right? So we connect it to the engine, and then let's see how it looks like. Okay, great. Now we have this curve. Maybe I can shrink a bit. Okay, curve starting from -5, -5, 0, and 5. And it's quite a very simple graph. To clarify, we can add axes and labels to see how it looks like. So maybe we can here add plt dot axh line. This is a bit, might, yeah, axis horizontal line, which is at the position 0, x equals 0, and color in, say, black. Likewise, we define axis vertical line, which is at 0 in black. Okay. Also, we can give labels. X label as X and Y label as maybe f of X. Which do you like? F of large upper X? Okay, let's see how it looks like. Something is wrong. Y label. Okay, let's run it. Okay, now it's very clear. The graph, yeah, okay, there's an origin here, x-axis, y-axis, and labels, x and f of x. Great. I hope you like this kind of. This technique is very useful. You will use it many times in the future, so please learn about it. Also, I drew just a polynomial function, but also not only polynomial functions, but also transcendental functions can be plotted. For example, trigonometric functions. Okay, let's try it. So we can just copy this up to here and put the box here and paste it here. So instead of writing, for example, return x times x, we can write, for example, before that, we need to import math. That's important. Import math and define function as, say, math dot cosine x times math dot pi. Okay, this will draw cosine x pi, okay, in the same range. So this should give basically the same thing in the same range, okay? Maybe this is not so pretty. You can have, yeah, maybe you can make it a little beautiful, but actually this is basically the same. Okay, maybe we can change this to -2, +2. And this will look like this, okay? Or how about other things, such as Gaussian function. Okay, Gaussian. Do you remember what Gaussian function is like? It's like math dot exponential, say x squared is just one way of putting it. Okay, let's take a look at it. Okay, this is the very normal Gauss curve or bell curve in the area of -3 sigma up to 3 sigma with average mean value of 0. Okay, beautiful. Uh, Lastly, I will show one more might be interesting example of entropy function. This is just used in information entropy story. So maybe you will have take a look later. But okay, so in this case, this is just maybe we can use p instead of x because it is customary to use probability p. And now we have negative p times math dot log 2 p minus 1 minus p times math dot log 2 p, 1 minus p. This will draw information entropy graph. Okay, so let's take and the area must be negative 1 to 1. Let's take a look. Of course. I should write. I should start from 1 to 100. I see. Minus 1. It should work. Of course, the probability should start from 0 instead of 1. Okay, let's run it. Okay, so this is how entropy graph looks like. When you learn about information entropy, you will learn about this. Okay, that's all for today. Today I showed you how to plot graphs, including transcendental functions. Okay, so I will continue this kind of topic. Please come back and see again. Bye bye.